I'm Daniel, and for my bad physics project, I'll be taking a look at Home Alone 2. In Home Alone 2, the main character, Kevin, is lost in New York, and he encounters two criminals that he's met before. These two criminals are in the process of robbing a toy store before Christmas, and Kevin takes a photo of them. And in order to save Christmas, he attempts to stop them by leading them to a house that has been booby-trapped. At this house, Kevin is waiting on top of the roof. When the two criminals find them, the criminals ask Kevin to toss down the camera, and in exchange, they'll let him go. So, Kevin says okay, and instead of tossing down the camera, he starts throwing bricks down at them. And here is the scene where this happens.
Okay, kid. Give it to me.
Direct it.
How many fingers am I holding up, Marv? 8. Okay, kid. You want to throw bricks? Go ahead, throw another one. If you can't do any better than that, kid, you're gonna lose. Harry, You got any more? Come on, Marv, get up. You don't have any more bricks. He's out of them. What? What?
So in this scene, I'll be trying to prove that Marv should have definitely sustained more damage than he did. He would not have just red marks on his forehead and be thinking all weird, but he would have definitely had a fractured skull and would have passed away. So to analyze this, first let's draw a diagram. Drawing a diagram helps you analyze the situation better and helps you get a good grip of what is really going on. So using these diagrams, let's determine what we know. So we know that the mass of a brick is 2.27 kilograms, and the height of the building is 3 stories plus 9 steps, which is around 14 meters. The height of Marv, or Daniel Stein, is 1.93 meters. Therefore, the total distance traveled by the brick would be the total height of the building minus the actor's height, which would be 12.07 meters. We also know that the acceleration on the brick would just be gravity. Therefore, it is 9.80 meters per second squared in the downwards direction. And we know that the initial velocity is 0 because the brick is not moving before Kevin drops it. And we are trying to find the final velocity. In order to find the final velocity, we will be using the equation v2 squared equals v1 squared plus 2a delta d. And we're going to try to solve for v2. So, substitute all your values into this equation. So it becomes v2 squared equals 0 plus 2 9.8 meters per second times 12.07. Then, you're going to get rid of the square on the left side by square rooting the right side. You will then get the v2 of 15.38 meters per second. However, we need more than just the final velocity. We need to find the energy. Therefore, we will be using the equation Ek equals 1/2 mv squared. So substitute your values in to get Ek equals 1/2 2.27 kilograms times 15.38 meters per second squared. After calculating, you'll get an energy of 268.47 joules. So, we have determined that Marv would be hit with a total of 268 joules in the head, which is definitely too much for a human head to handle. A human's skull can only handle up to 14 to 17 joules of energy before it cracks or fractures. Therefore, I was right. Marv would have definitely suffered worse injuries than he had in the clip. He would have passed away, and especially after being hit by 4 bricks, there is no chance of survival. However, what if Marv was wearing a helmet? Let's take a look. The average motorcycle helmet can withstand up to 140 pounds of force, which is equivalent to 189 joules of energy. Therefore, a helmet would not save Marv in this situation, unfortunately. I guess the helmet would not work. But if the helmet wouldn't work, what will? So let's try rearranging the situation a little more. Let's find out what height would Kevin have to throw the brick off of in order for Marv to be able to survive. Let's take a look. Before we start our calculations, let's determine what we know. So we know the mass of a brick is 2.27 kilograms. We know that the acceleration due to gravity would be 9.80 meters per second squared. We also still know the V1, which is 0. Then we also know the EK, which must be less than 189 joules because that is the absolute limit of the helmet. That is why I chose 140 joules so that Marv can get away unscathed without too severe damage. To solve this problem, we would need to work backwards. So using the equation EK equals 1/2 mv squared, you're going to substitute what you know. So it'll turn into 140 joules equals 1/2 2.27 kg times v squared. You are then going to isolate for v squared by dividing the right side by 1/2 times 2.27 kilograms. Then, plugging this into your calculator, you'll get v squared equals 123.34. To get rid of the squared on the left side, you're going to need to square root the right side. Then, after all the calculations, you'll end up with a velocity of 11.1 meters per second. Now that you have the final velocity, you can use the equation v2 squared equals v1 squared plus 2a delta d. Now, we are going to solve for delta d. So plug in what you know would be 123.34 equals 0 plus 2 times 9.80 times delta d. You're then going to isolate delta d by dividing the right side by 2 times 9.80. You will then plug this into your calculator, and then you should come up with the answer of delta d equals 6.27 meters. So in order for Marv to survive with a helmet on, the brick would need to be dropped from 6.27 meters high, which is around half of what it is in the original scene. Therefore, there is no way Marv could have survived the original scene. Okay, that's all from me.